The world of energy storage has taken a big step forward. A large-scale energy storage system has been designed that has achieved a world record-breaking performance, making it the most efficient energy storage system to date. The recently proposed system uses a combination of state-of-the-art technologies to store energy more efficiently, at a lower price and with greater capacity than ever before. This new technology indicates a massive leap forward in the potential for renewable energy storage solutions. This breakthrough could revolutionize the way we store energy and make energy accessible to everyone, even during peak hours. It could even help to reduce our dependence on fossil fuels and reduce emissions. With this breakthrough, the possibilities are endless. Join us in this video as we explore this new technology and how it is going to change the way we store energy forever. Renewable energy has made major headways in the past few years and paved the way for a new, cleaner, and greener future. The introduction of renewable resources to electricity infrastructure has led to increased customer satisfaction, and it has reduced dependence on fossil fuels. The argument against green energy is that it needs to be stored, requiring new infrastructure and energy-intensive technology. If we want to avoid the wastage of renewable energy on days of low demand or during its increased production, we need large-scale energy systems. Large-scale energy storage systems are used to regulate energy supply and demand, allowing for better energy management. They help balance out the load on the main grid by absorbing excess energy and releasing it when needed, helping to optimize energy production and distribution. These systems are the key to a sustainable energy future. They help us make the most of our clean energy resources, like wind and sun, and store them in times of high demand. For example, when there is a lot of available solar energy, it can be stored in a battery and used later when the sun isn't shining. This can help stabilize the power grid and keep electricity flowing reliably to homes and businesses. These storage systems are beneficial, especially for areas that are prone to natural disasters or power outages, because they provide a reliable source of energy even when the grid is down. Currently, large-scale energy storage systems rely on an off-grid market that uses diesel generators to store the excess energy. The problem here is that these energy storage systems cost a fortune to the government because of the increasing fuel prices. Plus, there are limited options available for such storage systems. On the other hand, there is an increase in energy production from renewable energy resources, and we don't have anywhere to store it. Further, the current energy storage systems are harmful to the environment due to their high carbon footprint, and must be replaced on a long-term basis. It is time that the world gets a better, greener, and more efficient way to store energy. Thanks to Professor Xavier Crispin and his colleagues at the Laboratory of Organic Electronics, it is possible now. They have found a new technology to tackle these issues by providing a cost-effective and environmentally friendly solution. A team at Linköping University led by Professor Xavier Crispin discovered not one, but two solutions to make the storage of clean energy a reality. One is a water-based electrolyte, and the other is electrodes made from lignin. Typical energy storage devices contain organic electrolytes, even though these electrolytes are not the ideal option. Organic electrolytes are costly, flammable, and detrimental to the environment. These electrolytes also have low ionic conductivity, so they render less capacity to the battery. Comparable to these, water-based electrolytes are far better. Water-based electrolytes are cheap, non-flammable, and environmentally friendly. They also have high ionic conductivity, so they would have higher capacities if used in energy storage devices. Unfortunately, water-based electrolytes cannot be used in energy storage devices because they have a high self-discharge rate when connected to organic electrodes. Due to their high ionic conductivity, the current leakage is greater, making the battery unfeasible. As a result, organic electrolytes are the only option left and are thus commonly used in energy storage devices. But guess what? The team of researchers at Linköping University has found that reducing the electrolyte self-discharge rate can decrease the current leakage and increase the performance and capacity of an energy storage device. They designed a polyelectrolyte by adding potassium polyacrylate to the water-based electrolyte. This modified electrolyte has every great feature the researchers need. It has a low voltage drop and a lesser self-discharge ratio, which tremendously increases the battery's capacity. The voltage drop in a battery containing organic electrodes in this newly designed water electrolyte was observed to be lower than 0.5 volt even after 100 hours. This is the lowest value of voltage drop ever recorded in energy storage devices, which is why the discovery of this new electrolyte is such a big breakthrough. As you know, the world has been increasingly turning to renewable and sustainable sources of energy. In the last few years, researchers have been focusing on developing new materials that are not only biodegradable, but also sustainable and environmentally friendly. The energy production sector is also cutting its greenhouse gas emissions by replacing fossil fuels with renewable energy sources. Wood-based materials and their derivatives offer great potential as resources for producing these new technologies. It is why the team of researchers at the Laboratory of Organic Electronics modified the electrodes used in energy storage systems to make them more eco-friendly and stable. They replaced the carbon-based electrodes used in conventional batteries with electrodes made from lignin, which is an organic polymer and a renewable material extracted from the cell walls of plants. Lignin is an excellent candidate for this research also because it is abundant and inexpensive. The electrodes produced from lignin are cheap to manufacture. In fact, even a kilogram of lignin does cost less than $1. So by replacing the traditional metal electrodes with lignin electrodes, the researchers could reduce the cost of energy storage devices. Lignin is widely available and can be produced sustainably without any additional carbon dioxide emissions, so it will not contribute to any pollution or greenhouse gases as well, unlike the other materials that are currently being used. These modifications to the electrolyte and electrodes made large-scale energy storage much more efficient, cheaper, and environmentally friendly. According to Professor Xavier Crispin, this new technology will allow for a higher power density than any other organic battery technology with the same weight and volume. The power density is recorded to be at 5 kilowatt-kilograms, which promises to be competitive when compared to lithium-ion batteries. Now that the materials have been identified, researchers are developing a completely new system for large-scale energy storage that uses lignin as the electrode and potassium polyacrylate in the electrolyte. The researchers at the Laboratory of Organic Electronics have manufactured coin cell batteries using the same technologies that they discovered last year. These small batteries are used in calculators, remote controls, and watches to test the researchers' findings on water-based electrolytes and lignin electrodes. The researchers believe that the new type of batteries could be used in large-scale storage systems like wind power storage and solar power storage. The batteries would be more efficient than those currently on the market due to their greater capacity to store energy. Furthermore, they are less expensive to manufacture as a result of being made from widely available materials and have fewer environmental impacts. If successful on a large scale, this new energy storage system will bring us one step closer to a more reliable and efficient energy production and storage system. It will play an important role in the managing peak electricity demand and also balancing the grid, particularly when the uptake of renewable energy resources such as solar and wind is reaching new heights. All the electricity wasted in such cases will then be stored and used when needed. The new system will be particularly beneficial for managing distribution in cloudy and dry locations where the solar or wind power plants produce less output because the system will deliver the previously stored energy back to the grid when demand is high. This large-scale energy storage system will also help to balance the grid when other technologies fail, such as during extreme weather events that might cause the shutdown of hydroelectric power plants, for example. All in all, with this new technology, the future of energy storage looks brighter than ever.